Hi guys, Miss Simmer here. I'm going to try to handle some of the problems that I've noticed from section 9.1, 9.2 that might help you with your quiz. So let me get started. First problem. This one comes from 9.1, is an isosceles triangle. I know it's isosceles because it says 26 and 26 on the sides, or whatever numbers that you were given, they're the same. And it's got a right angle, and it has a number going across. And they're asking you for this x value. Now, the first thing we want to recognize from a previous chapter is that it is an isosceles triangle, and an isosceles triangle with an altitude means that these two triangles are congruent or similar. So these would be equivalent, they'd be equal. It would not only be a perpendicular, but a perpendicular bisector, which means that this would be 24 and 24. Now, going to one of these triangles, our sides, it's a right triangle. X squared plus 24 squared is equal to 26 squared. So x squared plus 576 is equal to, sorry, I forgot my square of 26 right away. 26 times 26 is 676. And then when you subtract it, x squared is equal to 100. X is 10, the height of that triangle. So if you encounter that problem, hopefully that will help you out. Another one in that section was about how you tell if something was obtuse or acute. We know that if, for example, we had a right triangle with the sides 3, 4, and 5, that 3 squared plus 4 squared would be equal to 5 squared, or 9 plus 16 would be equal to 25. So what do we do when they're not equal? Well, we say whether the triangle is an acute triangle or an obtuse triangle because it's no longer a right triangle. Well, one of the sets of numbers that I saw was 0.4, 0.3, and 0.6. Well, first we assume that the hypotenuse is the largest one. So now we've got 0.4 squared plus 0.3 squared equals 0.6 squared. So if that, now we solve, we get 0.14 plus 0.09 equals 0.36. And then we see, okay, it's not going to be equal because this is 0.25 and this is 0.36. So it's not equal, but this one is greater. If the hypotenuse is greater, it's obtuse. If the hypotenuse, or what we tested to see if it was the hypotenuse, if this number is smaller, it would be acute. So this one gives us a right triangle, and this one gives us the obtuse triangle. All right, let's move on to some problems from yesterday's homework. I know 30, 60, 90, and 45, 90 triangles can be very confusing in some circumstances. So let's keep in mind first a few things about those triangles before we begin doing some solving. I'll give you some tips. First, the formulas for a 45, 45, 90, and by the way, a 45, 45, 90 can also be half of a square cut along the diagonal. So these sides would be the same, x and x. We can also use a and a or n and n, but when you have those two side lengths, this formula is x root 2. So I'm just going to take away that square for now. Okay, x square root of 2. So if you see some of the word problems where they're talking about a diagonal across a square, you're using this. Now for a 30, 60, 90, watch out, a 30, 60, 90 can have a lot of different orientations. And the key is one, this is the smallest angle, so this is the shortest side, x. This is the 90-degree angle opposite the hypotenuse, and the hypotenuse is 2 times the shortest side. This would be the longest side. And then the third side, which is in the middle, is x root 3. So one of the problems I'm going to do from section 9.2's homework was this one. It is a 30, 60, 90. It looked like this. And it said, find x and y. Now, it may be confusing that the formulas have x's. So what I'm going to do is I'm going to go ahead and change these to a's so that you won't get those confused with the x in this particular problem. Now, the formula says this is 2a and this is a. I know that because this is the hypotenuse, the longest side, and this is the shortest side opposite the 30-degree angle. I don't know why I put x there. Crazy. All right. So that's the shortest, and this is the longest twice as much. Now that means that this side is the a root 3 side. That's the formula that it's equal to. Well, can you see that a here has to be equal to 13? Because if we set that up as an equation and we want a by itself, we would divide by root 3. And when we do that, a is equal to 13. Now, do we have to do all the solving? No, we can just notice that the 13 is in the front. It matches a, so it must be a. So that means our y value is 13, and our x value here is 2 times that a value of 13, 26. So that one was number 13 in the last homework, but when you see that again, hopefully that will make more sense. Okay, here's another problem. It's a 30, 60, 90. And that 30, 60, 90 problem, before we move on to any 45, 45, 90s, gives you this. All right. Oh, I drew it a little crooked. Let me fix that up. Okay, let's make this the 30-degree angle up here. Because I want to change the orientation, because notice 30, 60, 90 triangles can be all sorts of different directions since they have those 2 different angles. All right, so this is your shorter side, shorter, and longer. This is the longest, but it's the hypotenuse. So a lot of times what they'll refer to is the short side and the long side or long leg. So if they say side or leg, make sure that this might be the longest side, but this is the long leg, and that's the hypotenuse. So when they're referring to that, I noticed in the problem that some of you may have been confused about that. Now, the one thing that they said is the hypotenuse is 23, and they wanted the short leg and the long leg. Well, let's go back to those formulas. Opposite 30 degrees is a, that's its formula. Opposite 60 is a root 3. And we already know that the longest side is the hypotenuse across from 23, that's 2a. And that's our formula, and that's what it's equal to, 23. So what's half of that? Half of that, 23 is 11.5. You can also say 11.5, but I know you guys like the decimals when you can use them. So if a is 11.5, we have 11.5 for this side. And we have 11.5 root 3 for this side. And it is perfectly fine to have 11.5 root 3. You can check it out if my math lab gives you any trouble with that. What we did here is we said this was 23 divided by 2. So this would be 23 divided by 2 times root 3. So this is another way that it can be written. All right. Now, I'm just going to throw in another problem. for 30, 60, 90, and then we'll move to 45, 45, 90. So what if you get something like this? It's a 30, 60, 90. You put your formulas, A, shortest side, longest side, hypotenuse 2A, and your long leg, A root 3, on this side. Like what? 9 is equal to A root 3? That doesn't make any sense. Well, it does, because A root 3 equal to 9, we can solve that. Now, what you learned was rationalizing in the first section that we did last week so that you could handle this problem. First thing you do is divide by root 3. So that means A is 9 over root 3, but it's not rational. And when I say it's not rational, what I mean is it has a radical in the denominator. We need to take it out. How we take it out is by multiplying by that radical. The numerator and the denominator gets multiplied. So we get 9 root 3. And remember, the square root of 3 times the square root of 3 is the square root of 9. And what is the square root of 9? 3. Now, if you put this into MyMathLab as your A value, it's not going to like it. The reason is it's not simplified. Still not, it's rational, but it's not simplified. 9 divided by 3 is 3 with the root 3 behind. So that A value, it required a little bit more work. So this would be 3 root 3, and twice as much, 2 times A, would be 6 root 3. All right, so we went over a problem that gave you A problem that gave you 2A, a problem that gave you A root 3 that was easy because it was in the form of a number in front of the root, and then a problem with a whole number where that root is so that you can see the steps to solve it. So those are all the possibilities with 30, 60, 90. Now, let's take a look at 45, 45, 90. Now, 45, 45, 90, if you have a side length like 4, and they tell you these are equal sides, and they don't write the 45s in, it's still a 45, 45, 90 because it's right isosceles. And if it's an isosceles, these base angles, those are equal. So 90 from 180 leaves 90. Split it in half. These are both equal, and they would have to be 45 each. So it may be pictured like that instead of that. Now, if this is true, then this is your formula x, and this is x root 2. So this side would be a duplicate of this one, 4. This side would be 4 plugged in for x with a root 2 behind it. Done. That's it. Hopefully those were easy for you. Now, if we had, let's say, 8 root 2 here for a 45, 45, 90. Well, again, x, your formulas, and x root 2. Well, this is very similar to the x root 3 problem that we did. The x value and the 8 are in the same position. So what does that mean? X is 8. And you're like, give me 5 of those, please, or 10. Well, there's another one. Now, many of you had difficulty with a couple of the word problems that happen in the third circumstance, such as it says the side length of the smallest square plate. So here's a square plate in which a 30-centimeter chopstick can fit diagonally without any overlapping. Well, this is 30, and this is a square, or it's supposed to be a square. So what do we have? A 45, 45, 90 triangle here and here, even in my crooked square. Do we need the whole thing? Not really. So we're going to get rid of this part. And we're going to treat it just like a 45, 45, 90 because these are equal sides, x and x. Those are our formulas. So this is x root 2. Okay, so x root 2, this formula is equal to 30. So very much like we did when we had a whole number equal to the x root 3 side, we have a whole number equal to the x root 2 side. So x root 2 equals 30. We divide by root 2. Cancel. And we notice it's not rational, so we rationalize. Sounding familiar from the last problem that I did back with 30, 60, 90. We get 30 root 2 over 2, because remember, square root of 4, 2 times 2, square root of 4, that's 2. That was really bad too right there, but. So, is this simplified? Yes, because the 3 cannot be divided by 2. So now for x, for both of these x values, your answer would be the 3 root 2 divided by 2. Now for the Chinese plate problem, I believe it asked you to round it. I forgot to write down whether it was rounded to the nearest whole number or tenths, but I'm sure it's tenths. So you may want to just put that into your calculator. You could do that in multiple ways. Of course, I did not bring my calculator for that. Let's see, the square root of 2. Okay. Square root of 2 times 3 over 2, or 1.5. We get 2.12, which doesn't seem quite, oh, it's supposed to be 30. Excuse me, guys. I made a mistake, so I'm going to go back really quickly. This is a 30. Some of you would have raised your hands by now and told me, don't do that. So this would be 30, and luckily that would make it a little bit easier because it can be simplified. I left the 0 off. Forgive me, please. So that would be 15 root 2. So now going back for a moment, with that root 2 times 30, that would make more sense. The side length would be approximately 42.4 centimeters in that case, which makes perfect sense. That would be much better, 42.4 centimeters. Although that should be a little bit, thinking times 15, sorry. Second mistake of the day, I put in 30 here because now I fixed that 30, so my apologies. 15 root 2 would give you 21.2. The reason why I knew that that was incorrect is your answer, if this is your hypotenuse, it's the longest side, so these should be shorter. So let's review again in case my two flubs made a mistake and mixed you up. Since x root 2 is equal to 30, we set those equal. We divide by root 2. Once we notice that 30 divided by root 2 is not rational and we're looking for our x value here, we multiply by root 2 top and bottom. Then 30 times root 2 is 30 root 2. Root 2 times root 2 is 2. 30 divided by 2 gives us our 15 root 2, which is the answer for the two sides if it was a simplified answer, but they asked for an answer to the nearest tenth of a centimeter on that chopstick one, the chopstick across the plate. And again, our plate completes the square. All right, I'm going to make a second video just to make sure that if you want, you can check out that video in just a moment.